I am a student of BSc 4C and today I am Ian Christian F. Domingo and today magdi-discuss ako ng two sample problems about concrete design, which is specifically sa columns. So first example is this one. Design a square-tiled column is to support an actual dead load of 575 kN and an actual live load of 770 kN. Assume F prime C or yung ating compressive strength of the concrete. So, ang value niya is 27.6 megapascal. And yung ating Fy or yung ating yield strength of the steel o ang kanyang value naman is 414 megapascal. Use 28 mm main bars and 10 mm ties. So, first, let us assume muna yung ating value ng AST or yung ating steel ratio, which is nag-assume ako ng 0.02 AG or AG, which stands for gross area natin. So, ang in-assume ko nga na value ng ating steel ratio is 0.02 AG. So, bakit siya? Bakit yun yung in-assume ko? Kasi, meron tayong ideal assuming, which is between 0.015 AG to 0.03 AG. So, dapat magpa-fall siya doon from 0.015 to 0.03 AG. So, 0.02 yung napili ko. Then, proceed tayo, which is next is yung dun sa may ating PU or yung ating axial force. Excuse me. So, paano natin makakompute? Computing po kasi muna natin yung PU. So, paano natin siya makakompute? Makakompute natin yung ating actual load or yung ating PU from dead load and live load. Kasi meron tayong formula na 1.2 dead load plus 1.6 live load. So, given naman dun sa problem natin yung dead load and live load. So, yung ating dead load is yung 575 kilonewton and yung ating live load is yung 770 kilonewton. So, substituting lang naman siya dun sa may problem natin or sa equation natin na 1.2 dead load plus 1.6 live load. So, we will get 1,922 kilonewton. Then, proceed ulit tayo, which is doon naman sa may pag-compute na natin ng ating AG. So, paano natin makakompute yung AG? Meron kasi tayong formula for PU, which is equal siya sa P times PN. So, tulad ng sabi ko kanina, yung actual load yung ating PU. Therefore, yung ating PN naman, siya naman yung nominal column load capacity. Then, yung ating P is still unknown. So, yan. Meron tayong formula nga for PU, which is P times PN. Then, paano natin makukuha yung AG through that? So, meron kasi tayong separate formula for P PN, which is yung ating P times 0.80 multiplied by 0.85 F prime C or yung ating compressive strength of the concrete, tulad nga sabi ko kanina, multiplied by AG minus AST plus Fy times AST. So, substituting lang natin yung mga given. So, yung ating PU is meron tayong 1,922,000. Bakit siya naging 1 million? Kasi, dun sa may right side of equation natin, puro Newton yon. Newton yung unit nun. Therefore, binago lang natin yung unit nung nasa left side, which is from kilonewton to Newton. So, 1,922,000 Newton equals 0.65. Ba't siya naging 0.65? Kasi nasa 2015 tayo na NSCP. Multiplied by 0.8 multiplied by 0.85 times 27.6 multiplied by AG minus 0.02 AG. So, ba't naging 0.02 AG? Kasi nga, di ba kanina nag-assume tayo ng value ng AST, which is, yun nga, yung 0.02 AG. So, sinasubstitute lang naman natin yung value ng AST na yun. Then, i-add natin siya sa 414 multiplied by 0.02 AG ulit. Then, using anyway, pwede siyang maging um, quadratic formula or pwedeng irekta natin sa may calculators natin. We will get the value of AG, which is 118,192 square millimeter. Then, through that, makukuha na natin yung ating B square or yung ating B. So, bakit natin makukuha yun? Kasi yung AG is equal lang naman siya sa B square. So, through AG, may value na tayo ng AG. Substitute lang natin. Then, makakuha na tayo ng value ng B square. So, equals lang naman siya. So, 118,198 square millimeter lang din siya. Then, i-square natin para makuha natin yung gagamitin natin na dimension ng column. So, meron tayong nakuha na 343.8 millimeter. So, in-square root lang natin yung 118.198 square millimeter. So, 343.8. So, pwede natin siyang i-assume or pwede natin siyang gawin na 345 millimeter. Therefore, gamitin na natin is 345 millimeter by 345 millimeter na column. So, next, doon naman tayo sa may gagamitin nating bars. So, paano natin malalaman yun? So, true, yung sa inassume ulit natin kanina na AST. So, meron tayong AST, which is 0.02 AG. I-substitute lang natin yung given or yung nakuha nating AG, which is yung 118,198 square millimeter. But, makukuha natin doon is 343. Alam naman na natin kasi nagagamitin natin is 345 by 345 millimeter na column. Therefore, yung 345 na yung gamitin natin or pwede natin siyang i-assume na i-square natin siya kasi i-square lang din naman natin kanina yun. Therefore, for computing AST, so we will be having 0.02 multiplied by 345 square. Then, mag-arrive tayo sa answer na 2,381 square millimeter. Then, yung number of bars naman natin is kukuha natin through that AST. So, number of bars is equal to AST all over AB. So, ano ba yung AB natin? Makukuha natin yung area na yon is through pi over 4 over 28 square. But 28 yung ginamit ko kasi kanina sinabi natin dito na use 28 mm main bars. Therefore, yung main bars natin is 28 yung gagamitin natin. So, para makuha natin yung number of bars, tingnan natin. So, nakuha natin AST kanina is 2,381. Then, all over lang natin siya sa pi over 4 multiplied by 28 square. Then, makukuha natin is 3.87. So, wala naman tayong makukuha na 3.87 na pieces ng bar. Therefore, round up lang natin. Lagi tayong mag-round up. So, 3.87. Round up natin, which is 4 bars. So, therefore, we will use 345 by 345 column with apat na 28 mm bars. Next naman natin is yung dun sa may maximum spacing of ties. So, alam natin na 10 mm ties yung gagamitin natin. So, dun sa A natin is 16 by D, D sub B or 16 multiplied by 28 natin, which is yung kanina rin yun, equals 448 millimeters. Then, another try is 48 times tie diameter is equal to 48 times yung diameter ng tie natin is sinabi natin is 10 millimeter diameter. So 48 times 10 is equal to 480 millimeter, which is mas mataas siya. So another try. Tingnan natin kung mas mataas to. Least dimension of column is 345 millimeter. So 345. So yung akin namang second sample problem is this one. So, calculate the ultimate actual load capacity of the composite column shown. Then, ito yon. So, meron tayong 480 by 480 millimeter na concrete. Then, assume natin yung F prime C niya is 21 megapascal and yung Fy niya is 250 megapascal for the W section. So, properties ng ating W by 14. W14 by 211 steel is weight niya is 315 kg per meter. Then, meron siyang area which is 40,000. Then, meron siyang depth or yung H na 399 mm. Yung IX naman natin is 1,107 by 10 or 1,107 times 10 raised to 6 millimeter to the fourth. Then, yung IY naman natin is 429 times 10 raised to 6 millimeter to the fourth. So, i-compute natin yung ultimate actual load capacity using 2015 na NSCP. So, first, kunin muna natin yung area ng concrete. So, meron tayong area nung meron tayong area which is yung 40,000. Then, para makuha natin yung area nung ating concrete, so, kailangan natin siyang i-minus sa gross area niya or yung total area niya. So, what is yung total area niya? Meron siyang 480 by 480. Di ba? 480 by 480 yung ating column. Therefore, yung total area niya is 480 square or 480 times 480. Then, i-minus lang natin yung area nung steel na 40,000. Then, nakukuha natin yung area nung concrete. So, 480 square minus 40,000 is mag-arrive tayo sa answer na 190,400 square millimeter. So, using 2015 NSCP, kunin daw natin yung phi PN, which is yung ating ultimate actual load capacity. So, meron naman na tayong formula nun, yung tulad lang nung ginamit ko kanina, which is P times 0.08 multiplied by 0.85 times F prime C AC plus Fy ASS. Then, yung fee natin is equal to 0.65 kasi nga ginagamit natin yung 2015 na NSCP multiplied by 0.8 times 0.85 times 21, which is yung ating F prime C multiplied by 190,400 plus 250 multiplied by 40,000. Therefore, meron tayong makukuha na PPN equals 6,967.3 kilonewton.